We start a new chapter today. Today's topic, as you can see from lesson 3.1, we will be graphing quadratic functions. And hopefully you remember this from your Algebra 1 experience, but the graph of a quadratic function will be a parabola, either opening upward or, of course, flipping over, opening downward. So we're going to be looking at a particular form of a quadratic function called standard form. And we're going to learn how to come up with key features and eventually come up with the graph of that quadratic function in standard form. And then the second part of the lesson will be to find and interpret the maximum and minimum values of a quadratic function. All right, so let's just jump right in. And the standard form of a quadratic function looks like this. We have what we call a quadratic term. This number a is the coefficient for x squared, so this is the quadratic term, followed by what we call a linear term. Linear means x is to the first power, quadratic x is to the second power. And then finally, after that, we will have a constant, a number without a variable. So this first function that we're given, and we've got several things to answer regarding this function, eventually leading up to a graph. If you compare this first function to what I've shown you as standard form, notice that the b number identifying the coefficient of this linear term is actually 0, because when b is 0, 0 times x is 0. So we don't have a linear term, and also if you look at this, the c would be assumed to also be 0. Okay, so we'll just keep that in mind. It's always helpful to identify the terms that you have to work with, because eventually we're going to be looking at a very important formula that utilizes these numbers a, b, especially a and b. Okay, so first of all, let's talk about the y-intercept. How do we find the y-intercept? And this is probably the easiest part of all that we're going to do in coming up with this final answer. The y-intercept is always found by looking at this constant, this number that I've identified as c. And the y-intercept will always be that number. And if you want to just call the y-intercept 0, like on your paper when you identify your answer to this, you could say y-intercept 0, or it's okay to put it as an ordered pair. The ordered pair will always be 0c. Well, in this case, that c is 0. So either one of these would be acceptable. Either just go ahead and tell me what the y-intercept number is, what number will the graph cross on the y-axis, that's what that means, or you can identify it as an ordered pair, 0 and then whatever that c number is in the function. Okay, now we get to a very important formula, the equation for the axis of symmetry. The way we find that, so to find this equation for the axis of symmetry, it's going to involve a formula that will be very important for other problems dealing with quadratics, especially word problems that we'll look at quite a bit later on. So do your best to really drill this little formula, and I'll explain how to come up with the numbers that fill in for these letters, these parts of the formula. The formula itself reads as the opposite of b over 2a, and where we get this b and a is from the standard form. So in our function, which only has a quadratic term, a, and this is always true, a is the number in front of x squared. So for us, a is going to be 3. We do not have a linear term, which means that b is 0. So if I plug directly into this formula, I get the opposite of 0 over 2 times 3. Well, 0 divided by 6 is just 0. All right, so notice that the answer needs to be written as the equation of a line. the axis of symmetry, or you'll hear me refer to it a lot as AOS, is a vertical line. So it needs to be written as the equation of a vertical line, which will be x equals, and the number that we've discovered that it should equal is 0. That's the vertical line. It's really just another way of saying the y-axis. But every time you write the AOS, I need for you to show it as x equals some number, not just give me a particular number. Okay? So the nice thing about this formula is we've basically answered two of these statements that the book is asking for. The x-coordinate of the vertex will also be whatever this number is. So it's as though, literally, you don't have to write this, but I just wanted you to see it this way. When we're looking for the vertex, we basically at this point know what half of it is. We know the x-coordinate, and it's pretty easy to find the y-coordinate, which we will do on the next slide, because we're going to include the vertex in our table. Alright, so finding the vertex means we take that number that we came up with as the AOS, x equals 0, and we just plug that back into our function for x. So when I plug 0 in for x, I get, obviously, y is 0. Alright, so what I'm going to do here is part B is make a table, part C is graph. We'll just put our points on here as we go. So there's our vertex, and then I'm just going to do some inputs. I'm going to let x be 1. Now remember to do the order of operations correctly. You do the square first. 1 squared is 1, and then 1 times 3 is 3. Alright, so remember our AOS, our axis of symmetry, you should be familiar with that word now, is the line x equals 0. Or, in other words, the y-axis. So this is a line that creates symmetry, therefore it makes it really nice to come up with other points without having to calculate them. We just match them up, same distance away from the AOS. Okay, these are called corresponding points on either side of the AOS. Okay, well, let's do one more input. We're going to do a total of 5 points for a parabola. So 2 squared is 4, 4 times 3 is 12, and without changing my units, 4, 6, 8, 10, I'm just going to say that's 12, and then I'm going to match it up over here. And now that's all we need, those 5 points, the vertex, and then 2 other points on either side of the AOS will be sufficient for drawing the graph. Okay? So we made a table of values that includes the vertex, and then we came up with 2 other points and matched them up using the AOS. And that completes the answer for the first example. Alright, let's do this next example. Remember, the standard form of a quadratic function looks like this. Well, in this particular function, I have a quadratic term. I don't have a linear term. Linear means x to the first power, so we can conclude that b is going to be 0. I do have this constant, so remember how we find the y-intercept? We just look at that constant. The y-intercept literally will be 0 and whatever c is. So in this particular case, the y-intercept is the point 0.06, or you could just say the y-intercept is 6. Okay, the equation for the axis of symmetry, let's just look at that formula again. We need to be really good at it because it really comes in handy with standard form. Alright, so the opposite of b, well, we said there is no b, it's understood to be 0, over 2 times a. In this particular case, the coefficient of x squared is 1. Well, 0 divided by anything is 0, so we got that same situation as the previous example. The equation for the axis of symmetry will be x equals 0. And that ends up being the x-coordinate of the vertex. Okay, just like that. The vertex is an ordered pair. If the AOS is x equals 0, that same number will be the x-coordinate of your vertex. Okay, well, let's find the y-coordinate of the vertex. So if I input 0, back into the function, or in other words, I'm finding f of 0, just to remind you a little bit of how function notation works. F of 0 looks like this. 0 squared is 0 plus 6. So when I input 0 into the function, I get an output of 6. So I can already tell that these are going to be pretty high up on the y-axis, so I'm going to do the axes in 2's. So 0, 6 would be right there. All right, let's do another input real fast. 1 squared is 1. 1 plus 6 is 7. So the point 1, this would be 1, 2, 4, 6, 7, and then match it up on the other side of the AOS. Input 2, 2 squared is 4. Sorry about that. 2 squared is 4, 4 plus 6 is 10. So the point 2, 2, 4, 6, 8, 10, and then the AOS allows us to match it up, and this will be our parabola. Okay, so we took care of B and C basically at the same time. All right, here's my last example for this type of problem. This time we have standard form and we have the quadratic term, that means the x squared. We have the linear term, that's x to the first, and we have the constant. Well, finding the y-intercept is nice. It's just the constant, or if you want to write it as an ordered pair, it would be the point 0.05. The equation for the AOS, it's the opposite of b over 2a, is how we find the number. And so in this case, I would be very careful because a lot of people miss the sign of this little formula. It reads the opposite of b over 2 times a. So just be really careful. B in this case is -8. A is +2. Okay, I just always look at this part in parentheses first. -8 divided by 4 is -2, and the opposite of -2 is +2. So remember to write the equation of the axis of symmetry. It should be a vertical line, and in this case it's going to be the line x equals 2. And that becomes the x coordinate of the vertex. Let's make our table, find the vertex. So we're going to input 2. So basically we're going to evaluate f of 2. And that looks like 2 times 2 squared minus 8 times 2 plus 5. 2 squared is 4. 4 times 2 is 8 minus 16 plus 5. 8 minus 16 is -8 plus 5 is -3. So the vertex is the point 2, -3. Okay, and we already know another point based on our previous slide. The y-intercept is a point on this graph, so there's no need to plug a number in when we already found a point, 0.5. That y-intercept means we're going to cross the y-axis at that point. And remember, we have symmetry. I'll just do a little dotted line. This AOS is our line of symmetry, x equals 2. So again, use that to help you come up with other points when you don't really have to calculate them. It's kind of handy. All right, I need another input, and what I always do is I try to fill in from the AOS outward. So if I have missing like a gap in my parabola, I like to fill that in. And what I mean by a gap is I have a point for x equals 0. When x is 0, y is 5. I have a point for x equals 2. That's the vertex, 2, -3. But you notice I don't have anything for x is 1. No point on my graph for x equals 1. So let's do an input of 1. Let's evaluate f of 1 in this function. So that looks like this. 2 times 1 squared minus 8 times 1 plus 5. 1 squared is 1. 1 times 2 is 2 minus 8 plus 5. And this is going to be -6. 2 minus 8 is -6 plus 5 is -1. So the point 1, -1 is on the graph, and that means this other corresponding point is also on the graph. And so I'm ready to draw my parabola. And that should take care of this problem. So I hope that gives you enough. You're going to be doing some problems very much like this. I tried to give you some good representatives of those types of problems. And then the second block of problems, your directions will change. Determine whether each function has a maximum or a minimum value, and then find that value. And then we'll talk about domain and range. Well, remember in our previous lesson, we talked about what this negative sign does when it's not involved inside in parentheses, or if it were absolute value inside the absolute value walls. This is just a minus sign in front of my function, and I don't have any grouping symbols basically. So the effect of this is to take my parabola and flip it over. Okay, so that negative sign tells me right up front that I'm going to have an upside down parabola. Alright, so it probably makes sense, since the vertex represents the very top point on that parabola, I'm going to have a maximum value. Now, what is that value? Well, that value is going to be the y-coordinate of this vertex. Okay, so whatever you find that vertex to be, the y of that vertex, the y of that ordered pair, will be considered the maximum value. So think back, how do we find the vertex? Well, we first found the AOS. Okay, so opposite of b over 2a. That means in this case that's going to be the opposite of 6 over 2 times -1. Okay, and in the parentheses I get 6 over -2, which is -3, but don't forget the opposite of -3 is +3. Okay, so now to find the y, or the number we're calling the maximum value of this function, we need to put 3 back into the function. We need to find f of 3. Alright, so this would be -9, 3 squared, and then the opposite of that, plus 18, minus 1. So it looks like it's going to be 9 minus 1, which is 8. So the answer to, first of all, do we have a maximum or a minimum? We have a maximum because the parabola opens down, and the value is the y-coordinate of the vertex. We found that to be 8. Okay, now let's think of domain and range. Alright, so maybe a little rough sketch at this point might help. So I'm going to say, you don't have to graph these, but let's say there's 3, 8, and we have a parabola that opens down from there, some parabola. Alright, so first of all, this is going to be true for parabolas. The domain is always going to be all real numbers. And you can probably tell that we're just going to, as we choose bigger numbers for x, this parabola is just going to continue to widen. And as I choose smaller numbers for x, it's just going to continue to widen this direction. So we're going to involve every single x number on the x-axis as coordinates for this parabola that goes forever and ever downward. Okay, well now let's state the range. Well, the range is only utilizing these numbers from +8 and downward. Remember, for range you're thinking of the numbers on the y-axis that are involved in this graph. So to state the range, I'm going to say f of x such that f of x is less than or equal to +8. Okay, from 8 downward, all of those numbers will be utilized as y coordinates as for this function. Okay. All right, so that's the complete answer of this. So let's try another one of those. This time we don't see the minus sign, so think of a parabola that opens up, and this time the vertex always represents either the very bottom or the very top. This time we're going to have a minimum, and minimum value at. Okay, well, let's figure out what that value is. Start with the opposite of b over 2a, and that's the opposite of 3 over 2 times 1, and that's negative 3/2. Or if you want to just use your calculator at this point, you could treat that as negative 1/2. Okay, so to find this value, we need the y coordinate of the vertex, which means we're going to input negative 1.5 in this function. We're going to plug it in for x and see what comes out. All right, so using your calculator, negative 1.5 squared plus 3 times negative 1.5 minus 12. And hopefully you've got your calculator going. And if I remember correctly, that is negative 14.25. And I'm just going to double check that real fast. Plus 3 times negative 1.5 minus 12, negative 14.25. Okay. And so what we found out is this vertex is the point negative 1.5, negative 14.25. The minimum value is the y coordinate of the vertex. Okay, now let's do domain and range. Well, you know what the domain is. It's going to be all real numbers. The range is going to be, this time we're going upward from negative 14.25. So this time you're thinking this is the very bottom, and we're going to take all the numbers going up the y-axis this time. So this time we're going to say f of x greater than or equal to negative 14.25. Okay, so I hope that helps on this one. And we got one more. I noticed that it's positive. Oh, be careful here. I just realized these terms are not in order. We need to do some rearranging first. We need to put this in standard form. Remember, standard form. Quadratic term first, linear term next, constant last. So we had to do a little switching. And now we see that this is going to be a parabola that opens down. The vertex is the very top, so we're going to have a maximum value at, okay, let's see, opposite of b over 2a, opposite of 8 over 2 times negative 3. So that's negative, the opposite of negative 8/6, which reduces to 4/3. And the opposite of negative 4/3 would be positive 4/3. So once again, if you want to just grab your calculator and change 4/3 into decimal form and round it, you can say 1.3. Okay. And it's going to be an approximation. So now to find out what the value is, we're just going to input 1.3. All right, and grab our calculator. Negative 3 times 1.3 squared plus 8 times 1.3 plus 2, and I got 7.33. So that ends up being, and it's rounded, but it's pretty close. That's going to be my maximum value. And now let's determine domain and range. Well, we already know what the domain is. And the range, since this goes downward, and this is at 7.33, remember the y. Remember y, we're looking up and down the y-axis. So at the very top of the range, we have 7.33 less than or equal to. So it's going to be all the numbers from 7.33 and downward. All right, so hopefully that helps you out. And then I don't want to work this out completely. I just wanted to give you some guidance on number 32, this word problem. What this amounts to is basically the same thing. They give you a function. I think it's already in standard form. If it's not, you can rearrange it so that it's quadratic term first, linear term second, then constant. See if you can find the vertex. Remember, it starts with opposite of b over 2a. That's going to be the f of my ordered pair, and that will be the answer to letter A of this problem. And then when you plug that number back in to the function and find C, you will have the answer for part B. So this ordered pair really is the answer. It's a two-part A-B answer, and when you find the x-coordinate of the vertex, you'll have part A. When you find the y-coordinate, you'll answer part B. So hopefully you'll be able to do that yourself with a little bit of this little tip, and we'll check these out next time.